Okay, so we're ready to start Chapter 7, which is entitled Exponential Functions. You should have your notes packet out, open to page 1, and a calculator next to your notes page. So the first two sections of Chapter 7 are rules of exponents and exponents that are not positive. We have here a listing from A through K on page 1, and also off to the right-hand side, examples. And we're going to go over the examples first and then look at the rule for each. So we're going to do example and then the general rule, example, general rule. All right, so let's start with the multiplication rule. Looking at the first example, we have a to the fourth times a to the second. Well, you've learned in previous years that when you have the same bases, a is the base, the 4 and the 2 are exponents. You've learned that when you're multiplying, what is it that you do with the exponents? You would add them. So we would have a to the fourth plus a to the second becomes a to the 4 plus 2, which would equal a to the sixth. So our rule is, in general, if we have a variable base of x, and we have x to the a times x to the b, that would equal x to the, we add those exponents, a plus b. The next rule, division rule. Look at the example first. We have 3 to the fifth divided by 3 to the fourth. Well, again, in previous years, what did you learn when you divide? What do you do with the exponents? You would subtract the exponents. So 3 to the fifth divided by 3 to the fourth becomes 3 to the 5 minus 4, which is simply 3 to the first, which equals 3. So, in general, variable base x raised to the exponent a divided by the variable base x raised to the exponent b is going to equal x to the a minus b. So when you're dividing like variable bases, you subtract the exponents, and let me go back up and for the multiplication rule, when you're multiplying like variable bases, you add the exponents. Next, we have the power rule. Again, let's look at the example. We have a to the fourth raised to the power of 2. Well, what is this? So for the power rule, here we have a to the fourth raised to the power of 2. So what does this really mean? If you had something squared, I would take a to the fourth times a to the fourth. And then, using our multiplication rule, this would be a to the 4 plus 4, or a to the 8th. In other words, if you have a power raised to a power, the rule is, what do you do with those exponents? You multiply them. This would be a to the 4 times 2, which is a to the 8th. So when you have x to the a raised to the power of b, this would become x to the a times b. So the power rule, what do you do with the exponents? you multiply the exponents. Our next example, we have 3abc raised to the third power. So inside parentheses here, we have this product. We have 3 times a times b times c raised to the third. What do we do with the exponent on the outside? We distribute it. So this becomes 3 to the third, a to the first to the third, b to the first to the third, and then c to the third. And 3 to the third is 27. So that's 27, a to the third, b to the third, c to the third. So in general, if we have x, y, z, this product raised to the power a, we're going to distribute the exponent a. So you distribute the exponent. So this becomes x to the a, y to the a, z to the a. Note, if it was an addition inside, if we had x plus y plus z raised to the power of a, you do not distribute the exponent. You distribute the exponent only when it's multiplication, all right? Only when you have a product of something raised to a power. So this x plus y plus z raised to the a does not equal x to the a plus y to the a plus z to the a, right? That's not the case. Next, we have our power of a quotient. Look at the example first. We have 3a divided by 2. So we have this quotient here raised to the power of 3. Well, we have a quotient raised to a power. So like we did for a product, we're going to distribute. In this case, we have a numerator and denominator. So you distribute the power into both numerator and denominator. So this is going to be 3a to the third over 2 to the third. And now use the product, the power of a product rule. That's going to be 3 to the third, a to the third, divided by 2 to the third. And we can simplify this, and this becomes 27, a to the third, over 2 to the third is 8. So in general, the quotient x divided by y raised to a power of a becomes x to the a over y to the a. Again, you're going to distribute in both numerator and denominator in this case. Zero exponent. What if we have here we have 9,999 raised to 0. Well, if you want, you can check it on the calculator, but anything raised to 0 power is 1. X to the 0 equals 1. 1 million to the 0 would be 1. Next, the 0 exponent with a coefficient. Okay? Look at the example. We have 9,999 times x to the 0. Now it's only the x that has a exponent of 0. The 9,999 does not. So only x to the 0 becomes 1, and this is 9,999 times 1, which is simply 9,999. So in general, if you had a coefficient, a times x to the 0, again, only the x has the exponent 0 associated with it. So this would equal a times 1, which is a. Next, if you have a negative exponent, all right, if I look at the example first, 3 to the negative 3. Well, to take care of negative exponents, one thing you can do is write the inverse or reciprocal of 3. We could write it using a positive exponent, meaning 3 to the negative 3 would be equivalent to 1 over 3 to the positive 3. And 1 over 3 to the third is equal to 1/27. So if there's a negative exponent, write it in the denominator with using a positive exponent. So x to the negative a would equal 1 over x to the positive a. This will take some time to understand, and you'll become more familiar with this after we've had some time to practice. Next, we have a fraction raised to a negative exponent. If I look at the example, we have this fraction 3 over 4 raised to the negative 2. Well, if you start off with a fraction raised to a negative exponent, what you want to do is invert the fraction, okay? Invert the fraction, or write its reciprocal. So this would equal 4/3 raised to the positive 2. And then 4/3 raised to the positive 2. Here we have a quotient. So distribute. That becomes 4 squared over 3 squared, which is 16 over 9. So in general, if we have a fraction, x over y, raised to the negative a, you want to invert the fraction. And raise it to the positive exponent. So this would be y over x raised to the positive a. Next, a fraction with a negative exponent in the numerator. Okay, let's look at the example. If I have this x to the negative 3 divided by 7. So I have in my numerator x to the negative 3. I'm going to take this and put it down in the denominator, right? Because it has a negative exponent. Put it down into the denominator. All right, so now there's just a 1 left in my numerator, and in the denominator now there's 7x to the positive 3. So in general, if we look at x to the negative a over b, take this, put it down into the denominator. So that would be 1 over b times x to the positive a. Fraction with a negative exponent in the denominator. Well, when we were in a numerator, we brought it down to the denominator. Well, now here, if we have our negative exponent in the denominator, move it up to the numerator, writing it as x to the positive a. So this would equal b x to the positive a over 1, but we don't write the over 1. Oh, I should have done the example first. Oh, actually, so you could do the example. Go ahead. Stop the video for a minute. Okay, so this negative exponent is going up into the numerator as 7x to the positive 3. Next page. Some examples. We're going to work through some examples, simplifying. This is a combination of the rules, applying a combination of the rules here. Now, there's more than one way to go about simplifying these, okay? And you have to figure out what way you're most comfortable with. All right, so I take this, I look at this, I have a fraction. My numerator is y to the 4th times y to the 3rd. Oh, I can do that. So that's going to equal, well, same basis. The rule for multiplication is you add the exponents. So that's going to be y to the 4 plus 3. And let me continue with that, which is y to the 7th. Now my denominator here has a y squared raised to the 3rd power. So this is a power to a power. And the rule is you multiply those. So this is y to the 2 times 3, which is y to the 6. So now I have a simplified quotient. I have just y to the 7th divided by y to the 6th. And when you're dividing, what do you do with the exponents? You subtract them. So this would be y to the 7 minus 6, which is simply y to the 1st. So this simplified equals y. Number 2, we have negative, or subtraction, x to the 5th divided by negative x raised to the 4th. Now, the only thing that has the power here in the numerator is the x. Right? That subtraction isn't associated with that power, that x in power. So you're just going to move that over into the answer. So we have negative and then x to the 5th divided by this negative x to the 4th. That does mean that you're taking negative x times negative x times negative x times negative x. Or I can think of that as negative 1. I'm going to raise that to the 4th because I'm going to distribute, and x to the 4th. Negative 1 raised to the 4th is positive, and x to the 4th is simply x to the 4th. So we have negative x to the 5th divided by x to the 4th. And now these are like bases, and for division we subtract the exponents. So that would equal x to the 1st, or simply negative x. Next, number 3. See this? Look at the numerator here. I've got this product raised to a power, so we're going to distribute that exponent. So this is going to become x to the 5th, y to the 5th, divided by, and I just have a product in the denominator. Okay. Now, the like variable bases. All right, I'm going to work at this, simplifying that. X to the 5th divided by x to the 1st is x to the 4th. And then y to the fifth divided by y to the third, you're going to subtract the exponents, and that would be y to the second. So that's equivalent to x to the fourth, y to the second. Number 4, I look inside parentheses, we have this product, x squared y raised to the k power. All right, so since we have a product raised to a power, we're going to distribute the exponent k. So this becomes x to the second raised to the k, and y to the first raised to the k. And when you have a power to a power, you multiply. So this is x to the 2 times k times y to the 1 times k. And no, you don't have to do every single step here. I know a lot of you that can simply say, okay, I've got to distribute, and that's going to be x to the 2k times y to the k. Now, here there's several ways to do this. I look inside here, and I would see this as 1/2 times x squared. Well, let's do that inside parentheses first. 1/2 times x squared, well, that's the same as x squared divided by 2. 1 times x squared is x squared over 2. All right, now I've got to take this and raise it to the negative exponent 3. Well, let's take care of the negative first. So take this fraction and invert it. So this is going to equal 2 over x squared raised to the positive 3. Now we have a quotient raised to a power. Distribute the power into both the numerator and the denominator. So this is going to become 2 to the third over x squared raised to the third. 2 to the third is 8, putting the answer up here, over x squared raised to the third, a power to a power you multiply. That would be x to the sixth. Next, we have 2 to the x times 2 to the fourth. Well, these are the same bases, bases 2. Right? You're multiplying. Well, when you're multiplying, same bases, the rule is, what do you do with the exponents? You add them. So that's 2 to the x plus 4. And that's it. That's the answer there. Number 7. We have x to the negative 1 times y divided by xy to the negative 2. Okay, again, there's several ways we can do this, but I'm going to take care of the negative exponent here. Put that down into the denominator, and the negative exponent here in the denominator is going to move up to the numerator. And when we move this down, it's going to have a positive exponent, and when we move the y to negative 2 up into the numerator, we'll then have a positive exponent as well. Okay, so this comes down, x to the first, and that goes up, y to the second. Now what stayed was this y here stayed, so that stayed in the numerator, and this x down here stayed in the denominator. So now I have y times y squared, which is simply, you add the exponents, y to the 1 plus 2, or y to the third, over x to the first times x to the first is x to the 1 plus 1, which is x squared. So we have y to the third over y to, or excuse me, over x to the second. Next, now look at this. I have 2x squared y for a numerator, 6xy to the negative 1 as a denominator. All right, well, I see that negative there, and I know I want to take care of that. I'm going to put that up into the numerator with a positive exponent. So let me just recopy this. So we have 2x squared, and that's going to be y times y to the positive 1 over 6x. So now we have division. Well, the 2 and the 6 we can reduce, right, to 1 and 3. And now x squared divided by x to the first, we're subtracting those exponents. So that would leave us with a x in the numerator. And y times y is y squared. So there's our result. We don't have to write the 1 in the numerator. We can just simply write it as x y squared over 3, because 1 times xy squared is xy squared. Okay, next, number 9, we have 4x squared y to the negative 4 times 4x y to the negative 3. All right, this is multiplication. So actually, instead of taking the negative exponents, writing them as positive exponents in the denominator, we're just going to do the straight multiplication here, right? You're going to multiply 4 times 4, right? So I'm taking 4 times 4, and then I'm going to multiply x squared times x, and I'm multiplying y to negative 4 times y to negative 3. And now apply my rules. 4 times 4 is 16. X to the second times x to the first is x to the third. And y to the negative 4 times y to the negative 3 is going to be y to the negative 7. We're adding the exponents. Okay, we can leave our answer like this, or we could write with only positive exponents, in which case we'd write 16x to the third divided by y to the 7th. Okay, that's enough for today. If you want, you can try. We'll pick up with 10 and 11 in class tomorrow. So for tomorrow, make sure you have your completed notes packet with you. And that's it for today.